columns. So 3 rows and 6 columns, it is easier for us to understand what is given. If the same thing increases, okay, increases into multiple dimensions, I mean, say for example, rows into column, 2 rows and 2 columns itself, you can see. So when the dimension increases, it is not possible for us to understand anything from the data. In such cases, we need to go for some kind of algorithms to understand the data what is given. Okay, so basically it is a tabular data where you have rows and columns, and the rows represents the records, the columns represents the attributes means the properties, you can say. So we'll also have, this is the regular table of data. We'll also have unstructured data. It can be a text, it can be an image, it can be an audio, it can be a video, or it can be an analog data, etc. Okay. So, I mean, despite the kind of data, we always convert them into arrays of numbers. So, whatever the data that we have, text or image or audio or video, whatever the analog data we have to convert the data into arrays of numbers. What do you mean by arrays? You will have again rows and columns. You will have rows and columns. In that form, you will be, putting the values. Next comes data type, the types of data. So common data, that built-in data types that we use are list, dictionary, str, int, tuple, set, all those things. This is with respect to Python they've given. Next, variables. Variables are of two different kinds. One is qualitative variable, the other one is quantitative variable. So what is this qualitative? So in the case of qualitative, it doesn't have the numerical value, it has only the categories. So again, the qualitative can be defined into two different kinds. One is nominal, the other one is the ordinal variable. So these two categories come under this. So what is this nominal and what is this ordinary? Ordinal, you may be asking. Nominal and ordinary, ordinal both are what to say? Both are having categories. Say for example, if I say, what example I can give? So we want to describe a person's height. Okay, person height can be, we can categorize into three different category: tall, short, medium. Okay, tall, short, medium are the three categories for a person. We can we can categorize. Okay, so in the case of nominal, you have only categories and you will not be having any order. So that is called as nominal variable. Whereas in the case of ordinal, you will have a order. You have a order in that. So by using that, we can, categories will be then and there will be some ordering also. That's why it is called as ordinal variable. Next comes quantitative variable, a broad category of the any variable that can be counted. It has a numerical value associated with. That's the reason it is called as quantitative. So it has, this category includes discrete and ratio variables. What is the difference between discrete and continuous variable? Anyone knows? What do you mean by discrete value and what do you mean by continuous value? Anyone knows about it? So any random value we can call it as discrete, whereas continuous means, say for example, the value ranges from 1 to 10, or it can be from 1 to 100, like that. So that is called as continuous value. Next comes descriptive data measures. How to measure the central tendency? Okay, and why is that required? So when we measure things of the same kind, say for example, we are measuring the same kind of things. So in that, what will happen is many data will cluster around the mid value. So such a value is called as measure of central tendency, or it can also be called as measures of location, or it can also be called as statistical average. So what are the measures that we use under central tendency are mode, median, and mean. So the formula also is given here. For mean, what is the formula? You know, the number of observations, the sum of all the elements in the set divided by number of elements. And median, number of observations plus 1 divided by 2. That is the median, the mid value, in other words. And the mode, the value which occurs most often is called as the mode. So these three describes the measures of central tendency. So why we want to do that? Because we see that some large number of measurements will cluster around the middle value. To measure those things, we are going for these measures. And next comes measure of dispersion. So it describes the spread of the data. So how the data has been spread, to measure that we go for the measure of dispersion. Under this we have a standard deviation, range, kurtosis and skewness. So these four measures we use for finding the spread of data. One is variance. So you all studied variance in the mathematics when we studied probability and statistics. Sigma square is equal to xi minus mu whole square. Sum of I is equal to 1 to n divided by n. And the range comes maximum value minus minimum value. And quartile. So when come to the quartile, it splits the values into, say for example, if data has some 100 values. Okay. So you want to split that into 4 equal parts. The first quartile divides the smallest to 25%. The second is the divides the value into 50%. Second quartile, which indeed is the median, gives a 50% of the value. Third quartile divides the smallest 75%. And the fourth quartile will be the end, till the end. So that's what they have divided the data into Q1, Q2, Q3. So first 25% falls under Q1, second 50% comes under Q2, and third quartile, the smallest 75% are the Q3. This is how the data has been divided into number of equal parts: 25%, 50%, 75%, then 100%. Next comes interquartile range. How to find the thing? It is this range is computed only for the middle 50% of the data. IQR is equal to Q3 minus Q1. Next comes coefficient of variation. It is a relative measure to compare the distributions with respect to the standard deviation. So when the value is greater, the variability in the data is irrespective of the scale. Next comes Z score. So it's a difference between a value and the mean of the set divided by the standard deviation. Next comes 5-number summary. The 5-number summary, it is used to describe the center, spread and shape of the data. So what is the center, what is the spread and what is the shape of the data will be given by the 5-number summary. One is minimum, maximum, Q1, Q2 and Q3. So how to find this? Shape of the data is found by this. Again, in that you have skewness, mode, median and mean. And using this you will be finding the skewness. If the mean is greater than median, it is a positive or right skew distribution, you can say. If the mean is equal to median, zero skewness or symmetrical distribution. If the mean is less than median, negative or left skewed distribution. Next comes box plot. So box plot, it is a visual representation of the 5-number summary. So it is used to check the presence of outliers. Whether the data is lying outside or not will be found here. Next comes covariance and coefficient of correlation. So it is used to find the variation with respect to the other variable. So between the variable x and y. This is a formula given for the covariance. And we will see how the Python code is associated with these EDA processing. So, are you all here? Yes?
Yes, ma'am.
Yeah, fine. So, any doubts with respect to the content which we had discussed so far? Anything you want me to repeat or any other doubts you have? So far, I spoke about the theoretical things. So I'm going to match those things, whatever that we have discussed with respect to the coding. I'm going to show the walkthrough of the Python code. So any doubts up to this, or shall we move on?
We'll move on, ma'am.
Yes. Thank you so much. So the theory content, whatever that we had seen, now we will implement using the Python code. So first thing is whatever the thing that you're going to do with the Python. First thing is you need to have these libraries. So these libraries are essential when you're going for processing the numerical value. Pandas in the case of when you go for finding the data set, and matplotlib for plotting the box plot or anything. Okay, so these three are the mandatory ones that you need to include in your file. So the screen which I am showing is the Jupyter Anaconda screen. I need to install that. It is a freeware only. You can install very well. And this Jupyter is a notebook which we can use for. It is very comfortable to use. So you can, easily type in the cell and you can get the result. When you click run, you can get the result. This is the run button. By giving the command, if you press run, you will get the result. The output will be displayed immediately. Okay, so this is very comfortable when compared to the command prompt usage and all. So the scripting part is also there. So when compared to that, this notebook, using the Jupyter notebook, you can always save the data and you can even refer it back. Whereas in the case of scripting, that is quite difficult. So it's better to go for Anaconda in the case of practice and all. So here I'm going to use the CSV file. That is the data set here is admission predict.csv. So what we do is we read the file and we try to know the top first 5 rows of the data. Okay. So what we do is data is equal to pd.read underscore csv. This is the format of code that you need to give. So my data set name is admission underscore predict.csv. CSV means comma separated values. Okay. If you open this file, you can see the rows and columns where the values are put up. Okay. If I give dot head, I will be displaying the top 5 rows of the data set. So you can see serial number is one column, GRE score, TOEFL score, university ranking, SOP, LOR, CGPA, research, chance of admit. So these are all the attributes that I have in my data. Now I want to check my dimensions of the data. So how many dimensions I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 columns. So here you can see data dot shape. So data as the you are reading the admission predict CSV file and you are loading it onto the data. Okay, the data will have the entire data set now. Okay, so now if you give data dot shape, it will return the size of the dimension of the data set, the data frame in it. DF means data frame. So what is the size of the dimension of the data set will be given here. So which means 400, 9. What is the meaning? We will have 400 rows and 9 columns. That is the meaning. We have 400 rows and 9 columns in our CSV file. That is the meaning here. Okay. So there are 400 observations or rows. You can also say rows, or you can also say 400 records. And there are 9 attributes. This is column wise thing, no? Serial number, GRE score, TOEFL score, university ranking, SOP, LOR, CGPA, research, chance of admit. All these are the columns which describes the data set. Okay. So next comes how to check the information about the data and the data types of each respective attribute. So the column labels are called the attributes. So how to check the information about the data? How we can check the information and how to check the data type. So what is the method that you need to give means data.info will serve this purpose. So data will have the entire data set. You read the data set, that admission underscore predict, you read and you are saved into data. Data will have the entire data set now. From that you give .info. .info if you're giving, then you will get the information. Say for example, serial number is one attribute, GRE score is the another attribute, TOEFL score is the another attribute. So where you can see non-null int 64, which means it is integer value. It is non-null, which means that it has some value. It is not 0. And similarly, GRE score, TOEFL score, university ranking, then SOP, float value. See, you can see int 64, and here you can see float 64, which means it is a floating point value where there, in the case of serial number and GRC score, it is integer type. So that's what you are looking at it. So 400 means, what is the meaning? So 400 data you will have in this. So 9 columns and 400 rows you have. That is the meaning. And data type, what are the data types that are used? Float 64. There are 4 categories: 1, 2, 3, 4. SOP, LOR, CGPA, and chance of admit are the floating point values. Whereas chance of, research, TOEFL score, GRE score, serial numbers comes under the category of integer. So that's why they have given this as 5 and this is 4. Number of floating point value is 4. Number of integer value is 5. Attribute. So 5 plus 4, it is 9 attribute totally. That is 9 columns we have. We can also say 9 attributes, or we can also say 9 columns. You all understood this one? Data.info will give you the data type of each and every attribute that is present in your data set, and it will also say the number of each category of the data type, and it will also say the memory usage. Any doubts? With a simple command you can get the values. Next comes EDA descriptive statistics. Any doubts up to this? Participants, any doubts? Yes? Any doubts?
No, ma'am. Please proceed, ma'am.
Yeah. Thank you so much. See, I keep on talking. There is no interaction, so that's the reason I wanted to check whether you're all
Yes,
there.
ma'am. Yes, ma'am. I can understand, ma'am. Yes, ma'am. No
Yeah.
problem, ma'am.
At least give me some yes, no, something like that. You can say, means which will make me to proceed further. I'm not getting any sort of motivation from you guys.
Yes, ma'am. Sure, ma'am.
Yeah. Thank you.
Thank you, ma'am.
So next comes the statistics with respect to EDA. So how to find the mean? This is simple only, but you should know how to use this. So simple thing, but with respect to Python, how to use it and how to get the values, we want to know. So you all know that we want to print the data and also the mean. So data.mean will give you the mean value with respect to each and every attribute of the kind, that the numerical value only it is considered here, because mean means, obviously you all know that. So the number of values divided by number of observation divided by n. You all know very well. Suppose if you have a categorical variable in the case of attribute, in that case this will not be applicable. You understand what I mean by categorical variable? Only with respect to numerical values this will work. So serial number, GRE score, TOEFL score, for each attribute they found the mean. It's a very simple function we are using, data.mean. We'll be getting the values. Next comes mode again. So for this alone, for GRE score alone, they found the mode. So mode, you all know that. So how many times the two values with the same frequency? So how many times it has appeared? There are two categories, 0 and 1. How many times it has appeared? So that's what they have given. Next comes median. So to find the median value, so for each and every attribute they found this serial number, GRE score, TOEFL score, university ranking, SOP, LOR, CGPA, research, chance of admit, data type. This is with respect to median. How to find the median? Next comes quantile. That is what we have seen, no? The quartile for 25%, 50%. I think the quartile, it is, the spelling is wrong. 25%, 50%, first quarter, second quarter, third quarter, that one. So how to find the first 25% of the data? So print of data underscore quantile within bracket. This is to print the thing. We'll give no printf statement we give in C programming, same to that. But the actual function that is used is data.quantile of q is equal to 0.25. You are setting the value to find the first 25%. And then for 50%, again, just you need to give, instead of 0.25, you have to give 0.50. And then next, for 75%, it is same. Just you need to change the q value to 0.75. So this is with respect to finding the quartile. Next comes how to find the summary, plotting the summary, mean, mode, and median using the histogram. So I have this one, three variables, mean, median, and mode. So for one attribute alone, I am finding I'm taking the GRE score attribute or the column value, and then I'm going to find the mean, median, mode for only this attribute, and then I'm going to print those values, and then I'm going to draw the histogram for that one. Okay, for which this code serves that purpose. So it is printing the value of mean, median, mode for the attribute GRE score. So for this attribute, we have 9 attributes actually, but we here you can see, yeah, we have serial number, we have GRE score, we have TOEFL score, we have university ranking, SOP, LOR, so many things are there. But we are interested to check only for the GRE score. So it is of type integer. So coming to this one, yes, this one I am giving the GRE score and finding the mean for GRE score, median and mode for the GRE score, and then so all these values will be displayed, and then the histogram is also plotted. Okay, to just plot the sum, mean, mode, and median. So how to using histogram, how to find this? Okay. I'll try to share this notebook. Only if you have Anaconda installed in your laptop or system, you can view this. Otherwise, you cannot view this file as such. Otherwise, I'll do one thing. I'll convert this file into PDF and I'll share it with you. I'll ask Saranya ma'am to share with you all. Okay, so that you can refer this. And next comes how to find the results provided by the 5 number summary. So already we had seen no 5 number summary, mean, median, 25%, 50%, minimum value, maximum value, 50%, 75%. So all these things can be found within a single command called dot describe. So data as the data set, entire data set is referred by data, and if you give data dot describe function, you can see the you can find the count for each and everything, for each and every attribute, the number of count and the mean value, maximum value, min value, standard deviation, 25%, 50%, and 75% within a simple command. So data.describe will give these values just like that. So how much ever big your data, you can easily view and you can see the summary of the data you can see. Next comes IQR value for TOEFL score. So quantile, here they have used the quantile as 0.75. So they have taken 0.75 minus 0.25. So data, the attribute that they use is TOEFL score dot quantile of 0.75 minus quantile of 0.25. Next comes understanding the summary statistics, plotting box plots. So here they take the attribute TOEFL score for which you are supposed to draw the box plot. Okay, third quartile, median, first quartile, minimum, maximum, and IQR. So using these things, we are going to draw the box plot. See, this is the box plot where you can see the first quartile, you can see the median, you can see the max value, you can see the min value. Okay, for the only for the TOEFL score. If I want to find the same for the other attributes, I can change the column name into TOEFL score instead of GRE score. I can give some other column name. What else I have? I can give university ranking, I can give SOP, I can give LOR, CGPA, research, chance of admit, anything I can put, and I can see the statistical plotting of the box plot. So instead of column is equal to TOEFL score, I can change it to some other column name also. So that for that particular attribute, the box plot will be displayed. So that's how I can see the plot the box plot. Next come check the measures of dispersion. In this, that's what 0.75 minus 0.25 for each and everything. They found this IQR value. And next range, maximum value minus minimum value. Data dot max minus data dot min will give you the range. And then variance also. Data dot var will give you no need to apply the formula and all we have seen, no. So no need to apply that. You can simply give data dot var. So Python code is very simple and easy for us to do the coding, so than any other thing for machine learning I'm saying. Then comes finding the standard deviation, data dot standard deviation. So these are all some of the techniques that we use in EDA. But with respect to your necessity and with respect to your project and your data set type, you need to use the appropriate EDA methods. Okay, it is not that all that will be applied. So for based on the data set and based on your requirement, you need to adopt certain strategies and you need to make it worthy. So yeah, not everything will be applicable. Sometimes you will not have any missing values, but you'll have some other errors will be there. So you have to replace the values in that particular cell with something else. So you need to clearly understand how the data set is, and you have to make use of the appropriate measure. So it is not that whatever that we studied, we need to apply. It's not so. So again, you need to understand this. These are all the techniques that you have. These are all the features you have. But then, which one you prefer? It is again depends on the data nature of the data set. With respect to that, and what is that? The thing which you want to find, based on that, the thing will vary. Okay, it's not that you need to adopt all the strategies whatever that we learn. Next comes covariation and finding the covariance and correlation. So data.cov will give you the covariance. Just like that, you can do this. So this they computed for all the columns, all the 9 columns, 9 attributes. They computed the covariance and correlation again for all the 9. Data.corr will give you just like that. It will give the correlation coefficient between every pair of attributes. It is given. And pair plot checking. So this pair plot checking it is used to find the histogram pair of attributes, and the histograms along the diagonal will be checking. So we use the Seaborn library file. Okay, and pair plot of data comma kind is equal to reg. So data whatever the thing that you have around 9, no. So for all the 9 that has been compared with the other things, and the it is data is plotted along the diagonal. You can see along the diagonal it is plotted. So here we can see the TOEFL, GRE, and CGPA scores are highly correlated with the chance of admission. All of the attributes have good correlation with the chance of admission. Apart from the target variable, there is a fair amount of correlation among the other variables. So by plotting this, we can understand the correlation how it is having among the other variables. So I compare serial number with maybe admission. I compare serial number maybe with a research. I compare GRE score with a CGPA. I can compare TOEFL score with the CGPA. I compare university ranking with the CGPA. Like that, I have to compare among the attributes, and I need to find out the how it is correlating using that, how it is correlated, it is having good correlation or not, or it does not have any correlation, or it is highly correlated. All these things will be finding with respect to this pair plots. Then heat map, how to drop a particular column. So if I want to drop a particular column which does not give any meaning to my data set. Say for example, in our data set, serial number, it is merely a data set, merely a column, but it doesn't serve any purpose, right? Do you all agree? So I have 9 columns here. One is serial number, the other one is GRE score, TOEFL score, university ranking, SOP, LOR, CGPA, research, chance of admit. Okay, there are 9 columns here. But so among the first one, if you see the serial number, which has only the rating 1, 2, 3, 4, 5, just it gives only that value, which is not all required like we feel, right? We are not getting any useful insight from that serial number. We are not getting any inference. So why to have that and have our data set occupies much memory. So what I do is I just drop that particular column. So for which what I have to give is data is the data set. dot drop of serial number comma access equal to 1 in place equal to true to drop a particular column from the original data frame. This is one way. If I want to drop some other column, GRE now, I mean score or TOEFL score or CGPA score or any, chance of admission, then you can give that particular column name, I mean attribute name here, and this and all should be as similar as such. Next comes how to find the heat map for the correlation. So the values will be posted here. See, for example, see here heat map for the table GRE score, TOEFL score, university ranking. Yeah, because we have eliminated the serial number. No, serial number we have eliminated. We are left out with only 8. So you see 1, 2, 3, 4, 3, 4, 5, 6, 7, 8. There are 8 columns, and again it is how it is correlated, how it is heavily correlated or lightly correlated based on the color it shows. The values also it is showing. GRE score and chance of admit is having 0.80, and you see TOEFL score with chance of admit is 0.79, and similarly university ranking with chance of admit it is 0.71, SOP with chance of admit it is 0.68, and LOR with chance of admit is 0.67. So this is the correlation coefficient it shows using the heat map. You can see for all the rows and columns how it has been correlated. Okay, this is the heat map through which we can understand the color intensity is based on how it is correlated, how strongly it is correlated. So that's what it is given. It's very simple. Just you need to give like this, then you will be getting the map will be generated. This is called as heat map. Next, how to check the skewness and kurtosis. So positively skewed, negatively skewed. So already I told you the formula. In case of positive, how it will be. In case of negative, how it will be. What is the condition? So if you give like this data.skew, it will give you the skewness for each and every attribute. These are all the positive, and some of them are having negative. SOP, LOR, CGPA, research, chance of admit are having negatively skewed, whereas TOEFL score and university ranking are in the positive skewness. Next, histogram for checking the skewness. So this is the code given. So you are plotting the histogram for GRE score to find the GRE score and its histogram and checking this one. It is a normal distribution with mean and value. So that's what this is the plot that you can see. So this is a form, this is a command that you give for finding this GRE score. Suppose if you want to change to some other attribute, you can also do that. Okay. So these are all the basics of statistical exploration. So this need to be done before you apply any machine learning algorithm. So before we go for any machine learning algorithm, we need not have to apply the data set as such. So you need to do some kind of cleaning, and you need to do some kind of processing before you feed the data onto the machine learning algorithm in order to get accurate results. Okay, so if you use the data set as such, it has missing values, it has errors, or it has some other noise. So with that, if you process the machine learning algorithm, you will not be getting the correct results. So you have the other technique as well. So let me tell you that also. Univariate and multivariate analysis. With that, our EDA part completes. So univariate analysis. So you from the name you can say that it is analysis of a single variable. So to find, the purpose of univariate analysis to summarize and find patterns. So what do you mean by pattern here? What do you mean by pattern? Say for example, in a class, so there are some 50 students in a class, and there is a course running. Say for example, data structures. So class A has 50 students, and they are currently undergoing the data structures course, and you have the test marks for that. So there is only one attribute, and you want to find the patterns of the data. Okay. So this can be done by means of univariate analysis. We have only single data. So how many students they come under the category of less than 50? How many students will come under the category of 60 to 70 or 70 to 80? Like that. So this is to analyze with respect to single variable. This is called as univariate. And bivariate, there is another thing called bivariate where multivariate or it is to find between more than two. So by not two, it is multivariate means it is more than two. So under this we have pair plot, scatter plot, all those things coming. Okay, pair plot already I have shown you, and you have something called scatter plot. Scatter plot will be of this kind. So it is a multivariate analysis through which we can find the correlation between more than one variable. So that is the meaning here. So data1.car will give you the data correlation between every possible pair of attributes. Next heat map for the same. Then how to use how to handle non-numerical data, that is categorical data. Already I told, no. Say for example height. If we talk about a person height, he can be, the height can be varied in three different categories. One is minimum, is tall or short or medium, we can categorize into. So how to convert these categorical data into numerical data for model building? How to do that is this what. So df underscore dummies. So we are creating a dummy database. With that we prefix park and columns parking area. In this case, they have taken this parking area column and then prefix is park. So with that, what they do is they attach the value for each and everything. So for each and everything, they attach the value. Say for example, it is of this kind. Okay, and I am giving a dummy data. It can be 0 or it can be 1. Parking is detached, that garage is called as 1. If it is attached, it is 0. Attached garage 0, detached garage 1. So like that you are categorizing, because it is a categorical variable, and categorical variable cannot be processed as such. We convert them into numerical value and then we do this is called as encoding, one hot encoding. This is one kind of thing. Then what else? This is the same code for this. And normalization and scaling. How to normalize the variables? Say for example, we convert different scales of measurements into a single scale. In that, what we use is we find the formula x minus mean divided by standard deviation, which will give you the standard scalar. We have a method called standard scalar to do this process. And what else? That's all. This is only for the categorical variable. So any other doubts, if you have, we can connect. Any doubts you can ask me. So these two files I'll share through Saranya ma'am. You can all refer. So it's a vast area. We just started with only the fundamental, the basic, very basic of machine learning part. So we are yet to learn so many things. This is just a beginning only, I can say. So that's what. So just a beginning, just a eye-opening kind of thing, I can tell you. So further, if you want to implement, there are many algorithms come into picture. There are three categories of algorithms. You all already aware of this supervised learning. In that you have many algorithms. Again, unsupervised learning. Again, you have algorithms, and many algorithms comes under that. And reinforcement learning. There are a lot more things to explore further. Just I told you how to clean up the data and what are the measures that we can adopt and how to proceed with it. That only the very basic or the very beginning part, and also correlated with the Python code. So it's a long way to go further. If you want to say for example, if they are approaching me for further sessions, we'll plan for supervised learning separately, unsupervised learning separately. Like that we can go for, and I have capstone projects also to discuss. But parallelly you can also work, only then you can understand what I'm trying to speak, because once if you listen, you won't be understanding. You hands-on coding also need to be done parallelly in order to make you understand the things, how it is working, all that you need to see. It's very simple, but if you practice the code, and it will be very easy for you. So those who are really interested, you can go to the Kaggle website. There you can find lot of this Python projects. You can make use of that, and you can try. So you can install the Anaconda software in your laptop, and this basics you can practice. So whatever that we discussed today, you can have a practice, and you can see how the data has been processed. You in the you can download the data set also from the Kaggle. So Kaggle is the useful source for learning the machine learning algorithms and the projects, all that you can Kaggle.com, ma'am. Once again, Kavipriya ma'am is asking. Kaggle.com. There are many projects with respect to this one machine learning they have in that. You can all practice, and many data sets also available free. You can download those data sets and you can apply these machine learning concepts onto that, and you can see. So any forthcoming sessions, I would welcome if they call me again, if they approach me again, and we'll go deeper into the concepts. So other than that, any questions from yours or from participants?
Dear faculty, kindly ask your queries to Bhavani ma'am.
Any feedback also is fine, because things will not improvise until unless you give feedback. Anything that you expect that anything is missed here, or anything you want me to further fine tune, it's I'm welcome to it. Please give your feedback, valuable suggestions or feedbacks from you. Then I strongly recommend. Maybe I'll correct in the next session. Nothing to say. Any positive thing or any negative, both you can, both are welcome.
Ma'am, mostly give positive response in the comment section, ma'am.
Yes, isn't it? I didn't go through
Yes,
that.
nice, ma'am.
Okay. Thank you so much. So anything they expect also, no need. I mean, they can feel free and they can express their views, ma'am. It's not like that. And I mean, forthcoming sessions, if you plan, also let me know so that I can give my best.
Okay, ma'am. Thank you, ma'am.
Thank you so
Thanks
much
for sharing.
for your patience and understanding. Thank you
Okay,
so much
ma'am.
again. Anything, if you want to contact, you please ping, take my mail ID.
Okay,
This
ma'am.
ID. Please ping to this, and we will connect.
Okay, ma'am. Thank you, ma'am.
Thank
Thanks for
you.
sharing your profound knowledge and
Thank,
insight into a passionate work, ma'am. Thank you,
thank you
ma'am.
so much.
Uh,
Very
Participant,
happy to connect with you all.
yes, yes, sir.
Thank you, ma'am. Thank you. Thank you, sir. Thank you, Satish Kumar, sir. And thank you, Saranya, ma'am, for the wonderful opportunity given in order to meet the participants and explain my views. Thank you so much. We will connect in other future session. Thank you so
Okay, ma'am.
much.
Thank you.